The universe, in its vastness and complexity, operates under a set of fundamental physical laws, among which the law of conservation of energy is perhaps the most crucial when discussing whether energy is ever wasted. According to this law, energy can neither be created nor destroyed. It can only change forms. This principle implies that no energy in the universe is truly lost or wasted. It simply transitions. For example, the energy from the sun travels as electromagnetic radiation, which is then absorbed by Earth and transformed into heat, chemical energy via photosynthesis, and other forms. From this lens, energy flows continuously, participating in countless natural processes. However, the question becomes more nuanced when we consider how useful that energy remains after it changes form. Not all energy transitions are equal in terms of usefulness, particularly when it comes to systems like machines or even stars. For instance, the energy that becomes low-temperature heat dispersed into space is far less useful in doing work compared to concentrated mechanical or electrical energy. Still, even this wasted heat energy contributes to the total energy balance of the universe. So, while energy isn't technically wasted or destroyed, it may become less accessible for performing useful work. A key concept in thermodynamics, the role of entropy and the second law of thermodynamics. To understand whether the universe wastes energy, we must explore the second law of thermodynamics, which introduces the concept of entropy, a measure of disorder or randomness. According to this law, every energy transfer or transformation increases the total entropy of a system and its surroundings. In simpler terms, whenever energy is used, some of it inevitably becomes more disordered and spread out, usually as heat, making it less available for useful work. For example, when gasoline is burned in a car engine, some energy powers the wheels, but a significant portion is lost as heat. While that heat still exists as energy, its disorderly form renders it practically unusable. This is what we typically refer to when we say energy is wasted. Yet, even this waste is part of a greater cosmic balance. Entropy always increases in a closed system like the universe. Over billions of years, this trend leads scientists to theorize about a future state called the heat death of the universe, where energy is evenly distributed, and no more work can be performed due to maximum entropy. Therefore, energy isn't lost, but its usefulness degrades. In this context, the universe doesn't waste energy in the human sense. Rather, it dissipates it toward a state of equilibrium, where nothing more can happen energetically. Black holes in the fate of energy. Black holes provide a fascinating lens through which we can analyze the fate of energy in the universe. When a star collapses into a black hole, it traps immense amounts of matter and energy within its event horizon, seemingly erasing it from the observable universe. This has long raised questions: does this energy disappear? Is it wasted? Stephen Hawking's theory of Hawking radiation offers insight. It suggests that black holes slowly emit particles over time, eventually evaporating and returning energy back to the universe, albeit over unimaginably long timescales. This implies that even energy swallowed by black holes isn't truly lost. It's just temporarily inaccessible. Moreover, the black hole information paradox, which explores whether information, a form of energy organization, is destroyed in black holes, adds another layer of complexity. Recent theories propose that information is preserved at the event horizon or through holographic principles, supporting the idea that energy and information are never truly wasted, just transformed in bizarre and non-intuitive ways. Thus, even in the most extreme environments, the universe seems to conserve energy in some form, reinforcing the elegance and robustness of physical laws. What seems like a cosmic deletion may actually be a cosmic transformation, misunderstood due to the limitations of current scientific observation. Human perception versus cosmic reality. When humans talk about wasting energy, we typically mean using energy inefficiently or in a way that doesn't serve our goals, like leaving lights on in an empty room or using fossil fuels instead of renewables. But this is a subjective definition rooted in human-centric utility. The universe doesn't operate on our values of efficiency or waste. It simply follows physical laws. From a cosmic perspective, energy transitions occur without judgment. Whether it's a star burning fuel, a rock rolling down a hill, or a galaxy colliding with another. Even chaotic events that seem wasteful from a human standpoint, like supernovae explosions or radiation lost into interstellar space, play critical roles in the cosmic ecosystem. Supernovae, for instance, scatter heavy elements necessary for life into the universe, so what may appear as energy wasted or chaos unleashed often serves a broader universal function. Moreover, our notion of waste depends on scale. What seems negligible or wasteful on Earth could be integral to balance at a galactic or universal level. In this light, the concept of waste becomes anthropocentric and not entirely applicable to the universe at large. Nature doesn't waste, it redistributes. The philosophical and practical implications, the question of whether the universe ever wastes energy isn't just a scientific inquiry, it also carries philosophical weight. It invites us to consider the value we assign to energy, work, and order, and whether those values are meaningful beyond our species and our time. From the standpoint of physics, all energy remains somewhere in some form. It is not wasted, only reallocated and sometimes rendered less useful. From a philosophical angle, the seeming inevitability of entropy, the idea that all energy will eventually spread thin and become unavailable, raises existential questions about the universe's ultimate fate. Still, this inevitability doesn't diminish the beauty or purpose of the energetic processes we witness now. Stars shine, planets form, life evolves, all due to dynamic and ongoing energy transformations. On a practical level, this understanding can guide us toward better stewardship of energy resources on Earth, recognizing that we can't stop entropy, but we can slow it down in systems we design, inspires innovations in renewable energy, efficient machines, and sustainable living. The universe may not waste energy, but we can certainly misuse it. By aligning our systems with the fundamental truths of thermodynamics, we move closer to a more harmonious existence, one that respects the cosmic dance of energy rather than working against it. In essence, the universe does not waste energy in the way humans define waste. Energy is conserved, merely changing forms, often into less useful states due to entropy. From black holes to burning stars, energy remains an eternal currency, always in motion, always transforming. The idea of waste is a human interpretation, one that reflects our needs and limitations more than the reality of the cosmos. The universe, in all its majestic indifference, plays by rules far more elegant and far-reaching than any human concern with efficiency.